You've seen multiple examples of training a machine learning model. Libraries like scikit-learn do the heavy lifting for you, allowing you to spend your time on data preparation. To predict the cost of homes, we use the XGBoost learning algorithm to train a model using the fit function. The fit function starts the training process, which iterates over the data to produce the model. In the log output, you'll see the listing of hyperparameters. This may be slightly confusing because we didn't set hyperparameters when initializing the learning algorithm XGB model. Since we didn't set the hyperparameters, default values were automatically used. Learning algorithms have default settings that generally work for most scenarios. When you train a model using its default parameters, your results will, on average, be fair. But the real game changer is going through a process called hyperparameter tuning. This is where you experiment with setting hyperparameters until you produce a well-performing model. What's the catch? Not all machine learning algorithms can be tuned, meaning they don't have hyperparameters that you can set to impact training and model performance. When selecting a learning algorithm, make sure to select one that fits your needs and performs well on your data. XGBoost is a tunable algorithm, unlike linear regression, with several hyperparameters. To see the hyperparameters available for your learning algorithm, use the getParams function. The output lists all of the hyperparameters available. You can usually gain a little extra performance by finding the optimum combination to provide the best prediction results. Good hyperparameter values can be found by trial and error for a given dataset. However, there are a few commonly configured hyperparameters for the XGBoost learning algorithm. As you review these parameters, you're reminded that XGBoost is a decision tree ensemble-based model. The first is N estimators. This is the number of trees in the ensemble, often increased until no further improvements are seen. This will increase training time and associated costs. The default value is 100. Next is max depth, the maximum depth of each tree. The values are often between 1 and 10. I typically experiment with this number until I see improvement. The default value is 6. Next, we have learning rate. The learning rate is used to weight each model, often set to small values like 0.3, 0.1, 0.01, or smaller. The default value is 0.3. Next, we have subsample, the number of samples or observations used in each tree, set to a value between 0 and 1. I often use 1 to include all the samples, and the default value is 1. The next one is column sample by tree. This is the number of features or columns used in each tree, set to a value between 0 and 1. I often use 1 to use all of the features. The default value is 1. Let's experiment with setting a few hyperparameters. We set them here. Now we can start the training process again and run predictions using the new model. We use the fit function to launch the training process, and then we run our predictions here, and then we compare the actual values to the predicted values. The next step is to review the R-squared metric. And here, the R-squared metric shows a slight improvement from 0.77 to 0.78. I will take it. Now, I challenge you to pause the video, pull down the code, and continue to experiment with tuning the hyperparameters. If you get higher than 78%, please let us know by adding a comment in the course Q&A. Now that you understand how to train a model and tune its hyperparameters, let's see the process in action from start to finish.